Hello students, and welcome to a dual lesson which will conclude this part of Unit 5. In this lesson, we will be looking at two skills. We will be looking at how to decide whether a relationship is a relation or a function when we're given a graph. So we will see a coordinate plane in this first half. And we will also learn to determine domain and range for all four ways of representing the relationships that we've looked at so far. So our essential questions are: 1. What is the vertical line test used for, and why is it effective? And we're going to learn that it's used to decide whether a graph is a relation or a function. We are also going to look at how can I perform the vertical line test. So how do you do this test? And third, what is domain and range, and how can we determine it? So we're first going to look at just part 1, which is deciding relation or function when given a graph. All you need in order to do the vertical line test, which will help you decide whether a relationship is a relation or a function when you have a graph, is a pencil or a vertical line. A lot of students like to use their pencil because it's a very handy tool that they have right there, but other students are able to just visualize a vertical line, and that's okay too. So let's first review this one fact. This is the basis of what we're going to be looking at today. Remember, a function is a special type of relation in which every input, which we know is the x value, has one and only one output, which is the y value. We know that this creates a consistent, reliable, predictable relationship that we can make predictions about. So the basis of the vertical line test is this. If a relation is not a function, then one input has more than one output. So for example, if we were looking at ordered pairs, we would see the same input, in this case 2, outputting two different numbers. Now, this is how we looked at a set of ordered pairs to decide. Let's now think about what that would look like on a graph. If we took these two ordered pairs and graphed them, first 2, 4, and then 2, -1, do you see how they lie on the same vertical line? If I drew a perfectly straight line vertically through one of them, it would connect to the other. This idea is the basis of the vertical line test, because if 2 points lie on the same vertical line, which is a line up and down, then they have to have the same input and two different outputs. So what is the vertical line test? The vertical line test is a visual used to determine if a graph is a function by deciding if every input has one and only one output, and if that's true, then it's a function. Or if any inputs have more than one output, and that would make it a relation. The relationship must be represented as a graph in order to use the vertical line test. The vertical line test only works if the relationship is graphed. So how do you perform the vertical line test? So here's how you do it. You slide any vertical line, such as a pencil, across the graph vertically up and down to see if any 2 points lie on the same vertical line. If there are not 2 points on the same vertical line, then the relation is a function. If there are 2 points on the same vertical line, then the relation is not a function and therefore just a relation. So why does this vertical line test work? If the vertical line touches in more than one location, it means that at least one input has more than one output and is therefore a relation. So remember when we had those ordered pairs, 2, 4, and 2, -1, and when we graphed them, they lied on the same vertical line. Because they were on the same vertical line, that meant the same input had two outputs and is therefore a relation. The opposite is also true. If the vertical line does not touch in more than one location, it means that every input has one and only one output and is therefore a function. So if we see points on our coordinate grid that are increasing or decreasing, and we can draw vertical lines and never touch another point, then we know that this is a function. So remember, the vertical line test is used to determine if a graph is a function. If you perform the vertical line test, it is said to pass if it does not touch more than one point. And if that is the case, then yes, it's a function. However, if you perform the vertical line test and you say that it fails, that means that it touches more than one point, and it is not a function, it is just a relation. So let's look at some examples. We're going to use this vertical line right here to test if this relationship is a function or not. Now currently we see that these 4 points are listed as ordered pairs, but we can put them on a graph because if we want to use the vertical line test, we have to have them graphed. So let's graph -3, which means go left 3 and up 3. 1, 2, 3. Let's graph 1, -2, so that's to the right 1, down 2. Let's go to 1, 1, over 1, up 1, and 4, 4, over 4, up 4. So here's our relationship, these 4 points. And if we were to slide this vertical line across, here this point's only touching once, but when we get to here, do you see how that vertical line is touching in 2 places? That means that this is not a function because 2 points are lying on the same vertical line. So is it a function? No. This is a relation because more than one point is touching the same input. This input of 1 right here had this output and this output. So it is therefore a relation and not a function. And you can see that from the ordered pairs. The same input has 2 outputs. Let's look at another one like that. Let's graph -2, -2, 1, 1, 3, 1, and 4, -2. And we'll slide that line across and visualize, is it touching at more than one spot at the same time? So when it gets here, it's only touching once, 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 once. So it passed the vertical line test. So is it a function? Yes, because no 2 points were on the same vertical line. And you can see from the ordered pairs, there were no repeated inputs. So let's look at these 4 graphs and try to decide if they would pass the vertical line test. Just start by drawing a vertical line on it. Here's a vertical line at -4. Do you see how it's touching in 2 places at the same time? And you can draw many to double check. Do you see how it's touching 2 places? Then is this a function? No, this is not a function. It is a relation. Okay, let's look at this one. Draw a vertical line. Is it touching at more than one spot? Yeah, it's touching at every spot. So is this a function? No, this is not a function. That's just a relation. Look at this one. Draw vertical lines. It's touching at one spot, one spot, one spot, one spot, one spot. So it's only ever crossing at one point at a time. So is that a function? Yes, this one is a function. Do the same thing for the 4th example. Draw vertical lines. That one was a little crooked. Draw vertical lines. Is it only ever touching at one spot? Yes, so is it a function? Yes, it is a function because it only ever touches at one point. So this is a function. What do you think about this graph? Would it be a function? No, because if you draw a vertical line, do you see how it's touching at more than one spot? Then this is a relation because it touches at more than one spot. As you think about this, you can pass your pencil because that's a very nice vertical line that you have, and again see that it touches at more than one spot and is therefore not a function because it's touching two y values for the same x value. What do you think about this one? Go ahead and take a second, drag your pencil across. Does it ever touch more than one spot? I only see it touching. It is only touching one spot at a time, so therefore that one was a function. So label it function on your paper. What about this one? If you drag a pencil across it, is it a function or a relation? It's a relation because you can see right here, it's touching 1, 2, 3 places at the same time, and therefore this is a relation. Label it on your paper, relation. It's touching 3 places for the same input. Let's look at this one. Drag your pencil across. Does it touch more than one place at a time? And the answer is no. And you can just zoom in a little more specifically here because this is the questionable spot. One spot, 1 point, 1 point. So therefore this is a function because it only ever touches one place at a time. What about this one? When you drag your pencil across, it's okay, it's okay, it's okay. It's okay over here. But if you would stop that pencil right here, you can see that it's touching all the way down and is therefore a relation because at this input there is more than one output. That makes it a relation. Graphs like this one can be very tricky. Closed dots mean that that is part of the graph, and open dots mean that it's not part of the graph. So if you draw a vertical line right here, it appears to be touching 2 places, but it's really not. This is the only one that's a point on the graph. This one is saying this is not a point on the graph. It gets very close to there, but this is a boundary marker. It's saying it is not equal to this, but it's very close to it. So if you draw vertical lines on this one, it only ever touches one spot, and here you can see it's touching here, but not here. It's touching here, but not here. And this is a function because it's only ever touching one place at a time. But you have to know that a closed dot means it's equal to or part of the graph, and an open dot means that it is not part of the graph. And you could slide that pencil across and see the same thing as long as you know that those open dots are not part of the graph. This is a function. So let's review lesson 4. Why does the vertical line test work? If the vertical line test touches in more than one location, it means that at least one input has more than one output and is therefore a relation. But the opposite is true as well. If the vertical line does not touch in more than one location, it means that every input has one and only one output and is therefore a function.